I request you please subscribe my channel. Currently you can see I have uploaded more video on many video on Raspberry Pi, Arduino, then Python programming, then some webinar, so that it can grow your career. So if you want to learn something from me, it is free, and you have to just click on this subscribe button, and all the video, it is very unique, and you will learn definitely many things from me. I uploaded mostly video on Raspberry Pi, mostly video on IoT, then Arduino. There are different types of project I have explained, and each project having the programming part. So please subscribe my channel, please support me, and please enhance your knowledge by watching my video. Hello friend, in today's session we will learn how we can design and develop a Proteus simulation of heartbeat sensor with Arduino. So in this project we will learn completely hardware connection, then I will explain each and every line of the program. So I request you please watch this complete video so that you will get idea about each and everything at the end of this video. Okay, before start the next part, I would like to tell you what will be the flow of this project. So you can see on the screen we have the heartbeat sensor, then we have the GSM model, then we have the Arduino and LCD. So basically whenever heartbeat sensor start reading the heartbeat, then whatever the heartbeat it will show on the LCD. Then if the heartbeat is below than 30 or above than 100, then automatically the GSM model will send the message to particular user mobile number, that is emergency condition. So this is the complete flow of this project. So I request you please watch this complete video so that you will get idea about each and everything about this project. Now let's see the practical demonstration of this project. Now you can see once we start the project, then you will see sensor not connected on the LCD because we haven't given the one signal to heartbeat sensor. So once we give the one signal to this heartbeat sensor, then heartbeat starts sending high or low pulses. If the Arduino detect the high pulse, then Arduino will count that heartbeat as a 10. If the Arduino detect the too high pulse, then Arduino will count as a heartbeat as 20. So within 10 seconds, if the Arduino detect the 4 high pulse, then at the end you will get the heartbeat is 40. If the Arduino detect the 7 pulse high pulse within 10 seconds, then you will get the count as 70. So why this is multiply by 10? Because I have set the time to read the heartbeat within the 10 seconds. If you have the patience and if you want to read the heartbeat within the 60 seconds, then I will tell you in the program you can remove that timer or you can increase the timer and you can easily detect the heartbeat within the 60 seconds. But for time being I only use the 10 second, and within a 10 second if the heartbeat is 7, 10, 7, let's say 8, then it will multiply by 10 and you will get the final count. So this is the logic. Now you can see on the screen, if I give the one signal here, then sensor connected and pulse is detected. If the pulse detected means high count is detected, pulse not detected means low pulse is detected. So I will start giving here one signal. So you can see timer is 12 second right now. Here you can see 12 second high pulse detected. So after 23 second approximate you will get the final count here. So wait for 10 second, or you can see from here 23 second, because we have given one signal at the 13 second. So plus 10 is 23, 22 approximate, you will see the final count. So you can see whenever the heartbeat send the high pulse, you will see 5 second 5 voltage here. Whenever heartbeat sensor send the low signal, then you will see 0 volt here, and that is captured by the Arduino here. You can see 5 volt is sent right now, high pulse is detected, again 0 volt is sent by the heartbeat sensor. Now after some time low pulse will be detected here. You can see low pulse. So this is the logic. Wait for 10 second. Now 70 second is there, 18. So approximately 23 second you will get the final count. Now you can see heartbeat is 105, because timing you can see here approximately 23 is there. After 10 second we get final heartbeat count. Now it's greater than 100, so that you can see on the GSM message, and GSM try to send message on this mobile number emergency condition. So this is the one part. Now we will see the low pulse. If the low pulse is detected also below 30, then what will be happen? Now again I start the program. So you can see heartbeat sensor monitoring system project display on the LCD, the name display on the LCD. Now sensor not detected. Now we are checking the condition if the pulse below than 30. So what we have to do, just give the high signal first here. So high pulse is detected. Now I will deselect this, so I will set logic 0. So every time it will show the low pulse right now because pulse is not seen. So you can see only one pulse is detected by the Arduino, Again wait for 10 seconds. After this, like you can see 3 seconds is here, approximately 13 seconds we will get the final count. And right now only one high pulse is detected because we have given only one high signal and then we stop the signal. That's why the count may be 10 or 20, in between 10 and 20. So you can see count is 15, that is low count, below than 30 pulse rate. Now wait for some second. Now it will send the message below because count is below than 30. So you can see again emergency condition message sent. So this is the second part. Now we will see the in normal condition what will happen. Now we are checking the normal condition. So in normal condition our count should be in between 30, greater than 30 and less than 100. Now sensor is not connected. Now I will again start the sensor. You can see high pulse, one high pulse detected. Count the pulses. 1, then second high pulse detected right now. Now third high pulse detected. Fourth high pulse detected. Then fifth high pulse detected. Then 6 high pulse detected. Now I will turn off this one. So right now we detected the 6 high pulse. Now you can see baud rate is 90. So count is like we may miss 2 high pulse. So count is 90 into 9. So that's why no message is sent here. So this is the basic logic behind this project. I hope you understand the logic and working flow of this project. Now we will see the hardware connection and then we will see the programming part. So first of all you require Proteus 8.9 software. I use Proteus 8.9 software. If it works on your another software then well and good. If it not work then you should use the Proteus 8.9 software. Second part is you require the Arduino software. You can see this Arduino software you require. How to install that Arduino software? So how to install that Arduino software I already explained in my this video, accident and alcohol detection Proteus video. So if you don't have the Arduino software, this Arduino software in your laptop, please watch that video and try to install that Arduino software. Okay, now the next part, if you have the Proteus 8.9 and Arduino software, next part we require the GSM library. How to install the GSM library in your laptop I will tell you right now. So first of all you need to download this industrial plant monitoring Proteus simulation folder from my Google Drive link. The Google Drive link given in the description. Okay, once you download this folder, that may be in the zip file, so you have to unzip that file. Then you will get two folder, Arduino code and Proteus simulation. So go inside this Proteus simulation, you will find the Arduino library and GSM library for the Proteus. So how to install that library in your laptop I will tell you. Just go to this GSM library folder. Again you can see there is a 3 files, so you need to copy the three files. So copy the 3 files, then go to the your C drive, then program 86, then labs and electronics, you can see labs and electronics, then Proteus 8, then data, then lib library, and here you can see whatever the library we copied, just paste that library here. I have already placed so that it is showing the this message me at your end it will copy and paste the GSM library here. With the same way you can install the Arduino library also. You can see there is Arduino folder, Arduino library folder. Again go to that folder and you can see there is library folder. Copy these two files, Arduino 2 files you have to copy, and again go to the same path, C drive, Proteus 86, labs and electronics, Proteus 8 data library, and paste the Arduino library folder into your this path. So it will install the Proteus library for the Arduino and GSM module in your laptop. Okay, once you install the Arduino Proteus library, now open the Proteus software, Proteus 8.9 software, right click here and run as administrator. Click on yes button. Then wait for some second, your Proteus 8.9 software will be open. Then go to the new project. Then after that you can give the project name whatever you want here, and wherever you want to save your project, that part you can give here. Then click on next button. Then select this create schematic from the selected template. Click on next button, select it, do not create the PCB layout. Click on next button. Here you select the no firmware project. Then click on next button and click on finish. Now you can see blank window will be open here. The first part is we have to load the Arduino file here. So go to the component mode. You can focus my arrow, then go to the component mode at this side, component mode, then click on P and type here Arduino. So once you type Arduino, you can see Arduino library will be open. We have to select the Arduino Uno. So type Arduino Uno. So once you type Arduino Uno, you can select this Arduino Uno and click on OK and place that Arduino Uno here. Okay, once you place the Arduino Uno, we have to give some default pin here. So go to the terminal mode, then click on default. So once you click on default pin, place one by one default pin in front of each pin. So you can see I am placing one by one pin in front of each pin here. So okay, then here also. Here also, and here also. After that, you can select all this pin at a time, right click and rotate 180 degree. Then after that, you can select again all this, just shift to the near to the Arduino. There should be one block gap between the two pins. You should not place that pin like this. You should place like this only. One block should be there gap. Then after that, you can connect one by one pin like this. So one by one pin you can connect like this. One default pin here should be one default pin, rotate 180 degree, then connect like this. Okay, then after that this pin also you can connect one by one like this. Okay, up till now we have connected the all default pin to the Arduino. Now next part is we have to give the name to this pin. So double click on the first pin. You can double click here and give your name RX, same name. Then give your name TX. Then give your name GPIO2, GPIO, GPIO2. So you can see GPIO2 I have given name to this pin. Then 3 number pin, double click here, give name GPIO3. Then 4 number pin, double click here, give name GPIO4. Then with the same name GPIO5, then GPIO6, then GPIO7, then GPIO8, then GPIO9, then GPIO10, then GPIO11, GPIO11, then GPIO12, then GPIO13. Okay, we have completed like this here. Then here you can see same A0, A0, A1, A2, A3, A4 and A5. Okay, we have completed this one. Ground pin should be connected to ground. So delete this and delete this VCC also. So select ground from the terminal mode. You can see terminal mode, then ground, and ground pin should be connected to ground. Then 5 volt should be connected to 5 volt. So go to generator mode, click on DC and take one DC supply here and connect that. So this DC supply here and connect that DC supply to the 5 volt. Double click here and give your voltage 5. So in this way we complete the Arduino part. Now we will connect the LCD with the Arduino. Now we will connect the LCD with the Arduino. So how to connect the LCD with the Arduino? Again go to the component mode, then click on P and type here 16 cross 2. So once you type 16 cross 2, select this 16 cross 2 LCD. Click on OK and place that LCD here. Then after that you can see RW pin should be connected to ground first. So go to a terminal mode, then click on ground and place the ground here and connect that ground to ground. Then we require some default pin. So go to terminal mode, then click on default. Take one default pin, right click, rotate anti-clockwise, place that default pin in front of RS. Copy that default pin, right click, copy to clipboard and paste in front of enable. Same right click, paste in front of the D4, right click, paste in front of D5, right click, paste in front of D6, right click, paste in front of D7. Then connect the default pin one by one here. You can see connect the default pin one by one. Then you require the RS pin should be connected to GPIO2. So double click on this RS pin and give your name GPIO2. Click on OK. Then enable pin should be connected to GPIO3. So double click here and give your name GPIO3. Click on OK. Then after that D4 should be connected to GPIO4. So double click here and give your name GPIO4. Click OK. Then double click here and give your name GPIO5. D5 should be connected to GPIO5. Then D6 should be connected to GPIO6 and D7 should be connected to GPIO7 and click on OK. So in this way we complete the LCD with the Arduino connection. Okay, after that we will connect the GSM model with the Arduino. So how to connect GSM model? I will tell you. Just go to the component mode, then again click on P and type here GSM. So once you type GSM, you will find GSM 900D. Click on OK and place that GSM here. Right click on the GSM, rotate anti-clockwise. So the GSM will become here. Just shift here. Okay, like this. So this RX pin of the GSM, you can see this is the RxD pin of the GSM. So RxD pin should be connected to GPIO 11. So we require one default pin. Go to default terminal mode, click on default, place one default pin here and connect that default pin here and double click here, give your name GPIO 11 and click on OK. Then this TXD pin should be connected to terminal, serial terminal. So where you find serial terminal, here you can see this one, serial here inside this, and here you can see virtual terminal and place that virtual terminal here. Then TXD pin of virtual terminal should be connected to RxD pin, TXD pin of GSM should be connected to RxD pin of virtual terminal. So connect pin like this. Like this we have connected. Double click on this virtual terminal, make sure your baud rate should be 9600 and click on OK. Then after that you can double click on this GSM model, double click here, double click on the GSM model. Here you have to load the X file of the GSM model. So go to the folder, then go to my downloaded folder from my Google Drive link. There you will find one GSM folder. So go to that folder, Arduino, then this one industrial plant, and here's Proteus simulation GSM library. So go to inside this folder, you will find hex file. Click on this hex file, click on open and click on OK. So in this way we complete the GSM part, LCD, and so in this way we complete the GSM, LCD and Arduino connection. Now once you connect the LCD GSM model with Arduino, now next part is we have to connect the heartbeat sensor. Now before heartbeat sensor, it is very important to install the heartbeat sensor library in your laptop. So firstly go to the my downloaded folder. So you can see this is my downloaded folder, heartbeat sensor Proteus. You will find this folder from my Google Drive link, the Google Drive link given in the description. So from this heartbeat sensor folder you can see there is a library, heartbeat library. So double click on this library and you will see the 3 files. So now click on these 3 files. So once you click on this 3 file, copy this 3 file and again go to the C drive. Then Lapsen electronics, you can see there is a Lapsen program C drive, then program 86, then program 86, then after that Lapsen electronics, then after that Proteus 8, then after that data, and then library, and paste whatever the file copy, paste the file. I already pasted my file, so that it will asking me replace, but at your case it will paste the file. So once you paste the file, again restart your Proteus software, close the Proteus software, and again restart the Proteus software. Then after that you can see, go to the component mode, click on P. After you restart, open the project and go to component mode, click on P, and then after you can see uh, here you can type the heartbeat. So once you type heartbeat, you can see this library, you will find this sensor. Click on OK and place that sensor here. So once you place that sensor, the connection is very easy. First part is you connect ground to ground. So go to the terminal mode, then click on ground and place the ground here, like here, and connect this ground pin to ground. Then again VCC, you need VCC supply. So go to generated mode, then click on DC supply and place the DC supply here, and connect the DC supply to this DC supply, like this. You can connect like this. Then after that, double click on the DC supply and give your voltage 5 and click on OK. Then after that, this test pin should be connected to logic state. So go to component mode, then click on P and type here logic state. Then after that, select any logic state like this and OK, and place that logic state here. Then double click on this and rotate 180 degree. Then after that, you can connect this logic state to here, to this point. Then after that, this output pin should be connected to analog 0 of Arduino. So you can see this analog 0. So we need one default pin. So go to terminal mode, click on default pin and place this here. Right click, rotate 180 degree and connect that default pin like this. Double click on the default pin and give A0. Name is A0 because we are connecting to the A0, because you can see default pin name is A0 here. Then after that, double click on this sensor, heartbeat sensor, and then go to the program files. Then after that, you can go to the downloaded folder again from my Google Drive link. So this is downloaded folder, heartbeat sensor, this one, and after that you will find heartbeat sensor library, and inside that you will find the hex file. So you have to load this hex file into this sensor and then click on OK. Then after that, your project is completed. Now next part, you have to load the hex file of this one GSM model. So double click on the GSM model, click on folder, then after that go to that folder again, you will find the GSM library. Go to here and select this hex file and click on OK and click on OK. So in this way your hardware connection is completed. Now next part is we will see the programming part, and then we will see how to run my ready-made project if you want my ready-made project. Okay, during hardware connection explanation, I forgot one point here. You can see this voltmeter is very important. If you not connect this voltmeter, then your sensor will not work. So how to connect this voltmeter, I will tell you right now. So I will first delete this so that I can explain you. So you can see up till here we have connected to the A0 pin like this. Let's say I will delete this object. Up till now we connected like A0 pin till here. Then go to this here you can see, and here you can find the voltmeter, DC voltmeter. Connect that voltmeter to here like this. Positive pin of this voltmeter should be connected to here, and negative pin should be connected to ground. So go to terminal mode and click on ground and place that ground here, and then only your project will be work successfully. Now we can see the programming part. So before start the programming part, it is very important, you should have this Arduino library, Arduino software in your laptop. So how to install this Arduino software, I already told you in my previous video. You can see this is the Proteus simulation accident and alcohol detection video. So in this video I clearly mention and explain how to install this software in your laptop. So if you don't have the software, please watch this video. This video link given in the description. Okay, so after you install the software, open this software, double click on this software. So after open your software, just go to the file, then click on open. So once you click on open, go to my downloaded folder link. All the folder link given in the description of this video. So go to the folder link, again this one, heartbeat sensor Proteus. Then you will find heartbeat sensor code. double click here and you will find this Iono file. So click on open button. So once you click on open button, the project will open ready-made. Now we will see the importance of each and every line from the code. So first line is hash include liquid crystal dot h. So whenever you require the LCD, so we have used the LCD in our project. So whenever you require LCD in the Arduino, you require this library. Then software serial is basically used to connect the GSM model to the Arduino. Then liquid crystal we can see we already saw that the LCD pin RS enabled D4, D5, D6 and D7 pin connected with the Arduino pin. So whatever the LCD connection pin that is defined here, so that's why here it is giving 2, 3, 4, 5. So 2 number pin is nothing but the RS pin, 3 number pin is enable pin, then 4 is D4, D5, D6 and D7. So whatever the pin we have used, that is defined here. Then my serial, the GSM RX and TX pin is connected to 10 and 11 number, that's why that pin is defined here. Then after that you can see pulse wire analog 0, because we have connected the pulse sensor to analog 0 pin of the Arduino, that's why defined here. Now in void setup, basically what we are doing, so in void setup what we are doing, basically the serial beginning you can see 9600 baud rate. So basically baud rate selection for GSM communication we are setting by this line. Then after that we are checking, we are using the 16:2 LCD, that's why that configuration defined here. Then at the starting we are printing heartbeat monitoring system on the LCD, that's why it is defined, that message defined here. Then after that while loop is started, where actually our program logic is start. So at the starting we are checking whether pulse wire, that is the input, this input 1 or 0. So how to read this input? To read this input we will use this logic. After value change, if the value is greater than 0, that means value is 1, then we have to start the heartbeat sensor, read the high or low pulse. If the output is 0, that means if this signal is 0 here, that means heartbeat sensor is not connected. So that we have to print on the LCD sensor is not connected if the value is less than 0, that's why this else logic will be executed. If the value is greater than 0, you can see heartbeat function will call. Inside this function there are some variable which count is basically variable, we store the final count. Then timer, it is used to monitor the 10-second time. And reading, it is a variable which read the 1 or 0 signal from the heartbeat, high or low pulses. So while 1 is actually the continuous part to for this logic, if the logic has to do in continuous manner till the 10-second completed, that's why it is a while loop here. Now here you can see first we are reading the pulses from the pulse sensor. If the pulse is greater than 0, then high pulse is detected, then we have to increase the count by 1, that's why this is the logic, and we have to print on the LCD high pulse is detected. If the count is 0, that the reading count is 0, that means low pulse detected, you can see low pulse we have to print on the LCD. Then there is some delay, and then timer is plus 600 millisecond. So you can see timer is 600, 600, 600, so it is continuously. So if the timer is greater than 10,000, that is 10 second. If the time is greater than 10 second, then whatever the count received from here, that high pulse count, it is multiplied by 15. So that is the logic to multiply the count. If you do not want to multiply this count, you can increase this second to the 60 seconds, 60,000 second, that means 60 second, and here then you do not need to multiply. So whatever the count you will receive, that count will be stored, and that is the real time count for the 1 minute. So I don't want to wait for the 1 minute, that's why I multiply here count by 15, and here I just taking the count for the 10 second, that's why here 10 second and multiply by 15. So I told the logic where to change the count if you want to wait for the 1 minute completely. Now I will wait for the 10 second, and whatever the count I will multiply by 15. So final count I will get here. Then I have to print that count on the LCD. You can see count print on the LCD. Then after that I want to send the message. If the count is greater than 100, then I want to send the message. If the count is less than 30, then also I want to send the message. If the count is in between greater than 30 and less than 100, no need to send the message. And to send the message, this function will be called, and definitely this AT command will be sent on the GSM model one by one line. You can see all the my serial print line is nothing but the AT command we are sending on the GSM model. So this is the logic to send the message. So our program is completed. I hope you understand the program completely. Now we will see how to run my ready-made simulation. If you don't want to do this circuit diagram by yourself, you can download my ready-made simulation. You can work on this. Now we will see how you can use my ready-made simulation and run the project. So first you need Proteus 8.9 software. So double click on this software, or right click on this software and run as administrator. So once you run as administrator, click on yes button. Then after that go to the open project. Then after that go to my downloaded folder. So folder link given in the description. So go to that folder, and after that you can see this Proteus file, you will see here Proteus project file. So click on this and click on open button. So once you click on open button, you can see ready-made project is available at your end, no need to create the project. Then after that first load the hex file of heartbeat sensor. So double click on this heartbeat sensor, go to this folder and load the heartbeat sensor hex file. You will find this file into the folder heartbeat sensor library. Select this hex file, click on open, click on OK. Then after that double click on this GSM model, then load the GSM hex file, click on OK, click on OK. Then here you will first check what is the baud rate of this serial terminal. So double click here, baud rate should be 9600. Then after that we need to load the hex file of Arduino program in our project. So how to load the hex file? So go to Arduino program and click on this verify button. So once you click on this verify button, you can see at the end you will find the ELF file or hex file path. So copy this path at your end, just ELF file or hex file path, copy this path completely. Then go to the Proteus, double click on this Arduino, click on this folder and type that path here, copy and paste that path here and remove one backslash. And then press enter. So once you press enter, you will see the hex file. So click on this hex file, click on open button and click on OK. Then after that project is completed. Now just click on this run button. So you can see once you click on this run button, the project start working. The project start working and you can see sensor not detected. Then you can give the one signal, then hyper slow pulse detected, and you can easily run this project at your end. So I hope you understand the complete project. Now if you like my video, please click on like button. If you don't subscribe the channel up till late, then please subscribe the channel and please support me. Thanks for watching this video.